talking about the definitions for organic chemistry, we know what organic chemistry is. It's just a branch of chemical chemistry that's studying um, products or compounds that are found in natural organisms. You understand? Such products include stuff like your carbohydrates, your protein. Those are natural resources, and that's where you find organic compounds. So organic chemistry is this branch of chemistry that studies these organic compounds. And most of the organic compounds are carbon-containing compounds. And when we say they are carbon-containing compounds, you understand, meaning they have carbons present in them. And although there are exceptions to these compounds, such as your carbonate, your carbohydrates, and stuff like that, those are exceptions to it. Good, because we don't have much time, we're going to be going straight to emphasize more on these compounds and talk about some important concepts before we even talk about them. Good. Now, the first concept I will actually bring into our notice is that an organic compound, I get it now, an organic compound are basically majorly made up of two parts. I get it now. Every organic compound are made up of two parts. And what are those parts? We have the functional group and the alkyl group. Every organic compound has a functional group and the alkyl group. That's it. All organic compounds contains a functional group and an alkyl group. Contains a functional group and an alkyl group. Now, when we say alkyl group, when we say alkyl group, when we say alkyl group, what are we really referring to? And when we say functional group, what are we really talking about? Now, you can be asked to define the following: functional group and alkyl group. Now, what is a functional group? Functional group. A functional group, these are a group of compounds, are you getting me now, that serves to be the reactive site of organic compound. So it is actually the functional group that serves as the point of reaction, the center for reactivity of any organic compound. Are you getting me now? Thus, it means that what your functional group in an organic compound is responsible for the chemical properties, the chemical behavior, and the chemical reactions that take place when that organic compound is actually present in the system of reaction. I get it now. So you can see that the functional group, these are the reactive sites. These are the reactive sites. I get it now, of the organic compound. OC stands for the organic compound, which controls what property does it control? It controls the chemical property. It controls the chemical property of the compound. So that's what we should take note of there. Our functional group is referred to as the reactive site and controls the chemical property of that group, controls the chemical property of that group. And it is very important. It is very, very, very important and key that you know that those functional groups are responsible for stuff like that. I get you now. Now, having talked about the functional group, we can now go further to talk about the alkyl group, which is the second part. We represent it usually as R. When we are talking generally, we represent it as R. Now, the alkyl group is just like, it's referred to as the skeletal chain of that organic compound. So it is the skeletal chain of the organic compound which is responsible for what? For the physical properties of that organic compound. Physical properties such as what? Such as the length of the organic compound. I get me now. So let's get that down. We are saying that the alkyl group, These are the skeletal chain. Skeletal chain. Or we can say the skeletal carbon chains. Skeletal carbon chains that are responsible or controls the physical characteristics, of organic compounds. So we usually denote it as R. Usually denoted as R. We are driving into it. Our basic aim for today is if we can be able to finish up with the learning, the naming, as the nomenclature of our alkane down to our at least let's go from alkane down to all our carbonyl groups, that is our aldehyde and our ketones. So maybe later on we can go into our amines, then we can now launch into benzene rings and stuff like that. You get that's our aromatic compounds. But today we are going to be looking deeply into the aliphatic sections, both the cycloaliphatics, you understand, and the aliphatic. All right, now, so we said this controls the physical properties of this compound. All right, without wasting much of our time, let's now talk about this important term which we call homologous series. Homologous series or homologous family. Now, when we hear the word an homologous series or homologous family, we're talking about, a family constitutes group of members, right? So we're talking about a group of members or group of organic compounds that serve as members which share a similar characteristics, possess the same functional group, and in which each member differs by a CH2 group. Are you getting me now? That's the basic concept behind homologous series. So we're saying that for the homologous series, these are groups of organic compounds which shares a similar characteristic and possess same functional group and in which each member differ by a CH2 group. Each member differs by a CH2 group. Very, very important. So we've been able to go through from our functional groups, we went down to our alkyl groups, then we now went further down into to talk about our homologous series. These are very, very, very important concepts, very important. So we said the homologous series is as a group of organic compounds which share a similar characteristics and possess same functional group, and in which each member differs by a CH2. I get me now. Okay. Now each member, if the name of each member is controlled by a sequence of prefixes. I get me now, which will be starting from med to et to probe and stuff like that. You get me now? So I'm saying that each member, the prefixes we're going to be using, for those that have one carbon, we use the word met, the prefix met. Those that have two carbons, we use the word F. 3 carbons, we use the word probe. 4 carbons, we use the word boot. 5 carbons, we use the word pent. This sequence continues this way. 6 is hex. 7 is hex. 8 is oct. 9 is going to give you 9 carbons. There are none. There are none. And 10 carbon, which is where we're stopping, is going to give us our check. Are we seeing that now? So those are actually the sequence that we are going to be using. Okay, those are the sequence we're going to be using in order to do some of these stuffs, in order to do some of them. Okay. Now, are we together? Let's write it down. I want to wipe off the board. Write it down quickly. Okay, Zina, how about, I don't know, Tulu and Tulu, Taiwo, and what's the other one, and Kendi, are they together here or they are sleeping? Which of the two is the response to this question I just asked? Quickly write. I asked the question. I said, Kendi, that's Kenny, Taiwo, Tulu, are they joining you or like they've gone asleep wherever they are? Which of the two is happening right now? Okay, I'll just move on. Now, we want to now further our topic. I want to talk about the nomenclatures. Like I mentioned some group of homologous families. We'll just take screenshots quickly. If you are done, tell me so that I can write it up. Okay. Now I'm going to give us a table, and that table is going to serve as a guide, understand, as a guide for our nomenclature. I want to just write the table and list of some organic functional groups that we're going to be doing today. Okay, that we're going to be doing today. So we're going to do it like this. We're going to say the functional group, the name of the functional group, the functional group. Then we will now look at, say, the name of the functional group. Then we also talk about the structure, or let's say the molecular formula of the functional group. Then the structure. So I'm going to do it like a table. Now, what are the functional groups that we have present? Okay, I'm going to log out and I'll come back online. Let me know what's happening in the group. Yes, I'm going to log out now and I'll come back right now.